Hello, everyone. So today we are going to be focusing on tan and cotan graphs. That's going to be combining 6.9 and then also 6.10. They go off of each other, similar to how sine and cosine does with secant and cosecant, because tan and cotan are reciprocals of each other. So they'll be very similar. These graphs are definitely more complicated than sine, cosine, secant, or cosecant. So just be aware of that, but also please keep in mind that the more that you guys practice, the more that you're gonna get the hang of this. All right, so it's gonna seem crazy at first because they are so different from sine and cosine. Okay, so we're gonna start with tan, which is 6.9. And similar to how we initially discovered sine and cosine, we created a table of values, right? So this is basically going to be our table of values. I'm just going to have us do a couple though, so that you guys can do, I'll say, the important ones. So let's see, and then you're welcome to either use, I know it says without using a calculator, but use a calculator, or you can practice using your unit circle. So as a reminder, if we were finding like tan of pi, well, tangent is y over x. So you would go over here to pi, and you would take the y value and divide by the x value. So that would be 0 over -1, which of course is 0, okay? So if you want, you guys can go ahead and pause this. Actually, I think all of these are pretty important. So just go ahead and pause this. This shouldn't take you really too long. And if you want to find those values, you can. But I'll be popping back up with the answers, okay? All right, so here are the answers. A couple things to keep in mind. If you chose to use a calculator, it's very important that you guys make sure that it is in radian mode, because these are in radians. If I had asked you for tan of 180 and you plugged into a calculator on radian mode, it wouldn't have gotten you the right answer because it's in radians. You need to change it to degree mode if you're dealing with degrees, and radian mode if you're dealing with radians. So that's if you're going to be using a calculator. The next thing to notice is that these two came up as undefined or domain error. So in sine and cosine, we never saw that happen, but we did see it happen last week for secant and cosecant. And do you guys remember what we did for the undefined values? They're asymptotes, right? So these are going to be asymptotes that we're going to put on our graph. Okay, so I'm going to use all of these values to go ahead and plot them onto here. You guys can go ahead and do the same, and let's see what this graph looks like. Okay, so here is everything plotted from this page. I know it's kind of hard to see, but these are going to be patterns that we're going to be picking up. So as you guys can see, there's an asymptote at pi over 2. And then if we add pi over 2 to pi over 2, we get pi, which is not an asymptote, but if we add another pi over 2, there's another asymptote. So you guys will see asymptotes at every other pi over 2 with tan graphs. And then you guys will see points on what we're going to call the midline again. So that kind of concept is still the same. So your midline is 0, just like all parents are. And you will always see points on the midline at every pi value. So if this is pi, what's pi plus pi? 2 pi. So there's actually a point there. Even though we didn't find it on the previous page, if you guys entered into your calculator on radian mode, tan of 2 pi, or use your unit circle, whatever makes the most sense to you, we get 0. And then same thing, if I subtract pi from pi, I get 0. So what is tan of 0? 0. Okay, so you guys will see points on the midline at every pi value, and then asymptotes at every other pi over 2. And then we have these points, these kind of points, these kinds of points. Well, think about what happened in secant and cosecant with the asymptotes, we use them as guidelines, right, to approach. So it is kind of looking like, oh, maybe this is a parabola again, but it's not, because see how this points down here? So these definitely aren't parabolas up or down. Instead, tan graphs are actually cubic. It's a bunch of cubics in a row. So that is what tan looks like. This is one period though. So secant and cosecant have two parabolas in one period. For tan, there's only one cubic within a period. So a period is from asymptote to asymptote, okay? And that's what tan looks like. And then of course, there will be a shortcut to graphing this. You don't have to use a table of values unless you want to. So here is our generic equation. The A is still called the amplitude. The B still helps us find the period. The only difference is instead of 2 pi over B to help you find it, notice, so the parent period for sine, cosine, and then even cosecant and secant, the parent period is 2 pi, right? That's why we do 2 pi over B. The parent period for tan, how big is that from asymptote to asymptote? How big is that? That's pi. It's this big. It's 6 boxes on this graph. So what that means is that the a full period is pi. So to find the period, instead of doing 2 pi over B, you do pi over B. You just drop that 2. The C is still going to be your midline, which is a vertical shift up and down. And then to find the vertical asymptotes, you guys can take pi over every 2b, and that's how you get the every other. So that's why you see it here, every other pi over 2. Okay, so let's get to graphing. Let's kind of check out this shortcut that I'm talking about. Actually. All right, so let's start kind of easy with number 1. We'll do this one together, all right? So I like to start with the midline, just like I do with sine and cosine. So as you guys can see, there is no midline, right? So you don't have to graph it, but I like to, just to kind of give me a guideline. So that is for sure my midline. It's going to be the middle of my S's, right? The cubics, and that's actually going to be the points on the midline. The next thing I like to do is find the period. So the period is going to be pi over B, not 2 pi, right? And what's my B value here? It's the number in front of X, which there is no number, so that's a 1. So my period is actually going to be the same as the parent on the previous page. This guy is my amplitude, which is 3. I'll show you how to use that. And then the next thing I like to find is my vertical asymptotes. So again, the formula for that is pi over 2b. So if b is equal to 1, that means that my vertical asymptotes are at every other pi over 2, just like the parent. So that's actually the first thing I like to graph is my asymptotes. So we're going to start at pi over 2. And then I'm going to, this is pi over 2 plus pi over 2 is pi, but remember it's every other pi over 2. So pi over 2 plus another pi over 2 is 3 pi over 2. So far this is looking very similar to the parent. In terms of graphing the points on the midline, it's actually very similar to sine, where you guys take the 2 outer points, or in this case, the 2 asymptotes, and you count exactly halfway in the middle. So exactly halfway in the middle is going to be my point on the asymptote. Okay, I'm just going to do 1 period for now. Then we're going to mark the quarter points, just like with sine and cosine. So from here to here, what's the quarter? Halfway. It's right there. And then from here to here, what's the quarter? Halfway, right there. So to create this S shape, that's where the amplitude actually comes in, that 3. So the S shape goes up like that. So we're going to go to this, and we're actually going to go down the amplitude amount. So from this quarter point, let's go down 1, 2, 3. And that's how you show your amplitude. And then right here, up 1, 2, 3. And right there, that's 3 points. With sine and cosine, I wanted to see 5 points per period. With tangent, you can just show me 3. And then don't draw a straight line. Remember that these are S's and that you should be approaching your asymptote. So to connect them, just draw the best kind of S shape that you can. And that's one period. All right. So one period is fine on your homeworks. Just be aware that on my keys, I typically show at least 2 periods. Sometimes I'll just do the whole thing. So, you know, points on the asymptote are always going to be every pi, or sorry, on the midline. Then I count halfway, and I go up 3, halfway, down 3, halfway, up 3. And this is actually this asymptote. So there's the second full period, and then I can fit a half period. So right there is 1, 2, and a half periods. Okay. All right. Let's try another one. For number 2, it's literally the parent, but shifted down 2. So I don't really find that one necessary, but it's literally going to look like what we drew down here. Just everything is shifted down 2 units. Okay. Let's try number 3. Very interesting. So number 3, there is no midline because it's +0, right? I still like to draw it. There's no midline. The midline is 0. I mean, there's no C value. God, all right. And then our period is going to be pi over b. Now look at that. That's the size of your period. We're used to the size of the period being this big, pi. So our period is going to be 1/4 of that size. Whoa. So that's your period. And then your vertical asymptotes are going to be pi over 2b. Holy crap, those are tiny. Pi over 8. Wow. And then finally your amplitude, there's an invisible 1 there. So your amplitude is just 1. Okay. All right, so first thing I like to do is draw my vertical asymptotes. So they're going to be at every other pi over 8. So pi over 8, that's half of pi over 4, right? And pi over 4 is halfway between 0 and pi over 2. So that's pi over 4. So pi over 8, zoom in, is going to be halfway between here and here. So it's literally going to be like 3/4 of a box. This is tiny. All right. So that's 3/4. If we add another 3/4, we get to there. And then add another 3/4 because remember it's every other. I'm only going to do 1 period for this because this is ridiculous. That's how big your period is. Isn't that insane? It's tiny compared to this. Okay, so there's our asymptotes. Next up, whatever your period is, that's actually always going to be a point on your midline. So we're going to plot a point on pi over 4 right there. And then we're going to use our amplitude of 1. So we're going to do our best to go about halfway and down, halfway and up. I mean, this is very much just a sketch because it's so tiny, it's hard to show those details. But still draw me your best S, like that. Isn't that insane? So look at the difference between these 2 periods. So you can have a really small period too. Okay. All right, and then the last tangent we're going to do together is one with a phase shift. So yes, tangents can have phase shifts also. Okay, so let's start again with the midline, which there's no C value, so that means that my midline is at 0. All right, the period is bigger. So the period, the B value is 1, so the period's just pi over 1, which is pi. And then your vertical asymptote is pi over 2b, which is just pi over 2. So your vertical asymptotes are going to lie at pi over 2 and then every other. And then your point on the midline is going to lie on that value. Okay. So here's pi over 2, every other. And then you can even verify, like, what is the size from asymptote to asymptote? That's pi big, right? It's 6 boxes, which as you guys can see from 0 to pi is 6 boxes. So that is the size of our period. And then we will plot a point exactly halfway. Sorry, you couldn't see that. Halfway, which is there. Then to show our amplitude of 2, we count halfway and down 2, and halfway and up 2. Like that. Okay. If you guys are curious, I'm not going to have it in any of the classworks or on the test or anything, but if you're curious, how would a negative tan work? Like, you know how for sine, instead of going up and then down, a negative sign goes down and then up. And then similarly for a cosine, instead of going starting above and ending above like a smiley, it's actually a frowny. That's how you show negative sine and negative cosine. So how would you show negative tangent? Instead of an increasing S, you count halfway and go up, halfway and go down. It would actually be a falling S, like so. This actually gets really confusing because that's actually what the CoTangent graph looks like. Not like this. This green one is not the CoTangent graph. It just looks like that. Okay. So speaking of, let's get into CoTangent graphs. All right. So let's first fill this out because we did this in the warm-up. So tan of 0 is just 0. And tan of pi over 2 is undefined. Tan of pi over 6 was, well, I don't want to leave it as a decimal, so let's make it a fraction. So if we actually use our unit circle, we do y over x, we do 1/2 divided by, and then do KFC, flip that, you get 1 over root 3. So that's how I'm going to write it instead of 0.6. Pi over 4 gets us 1. And then pi over 3 gets us root 3. So how are we going to show cotan? Well, as a reminder, cotan is the reciprocal of tangent. So we're literally going to take all of these and just flip them. So what is 0 over 1 flipped? 1 over 0, and what's that? Undefined. So notice right there, this is exactly like the reciprocals sine and cosecant and cosine and secant was whenever there was a 0, a point on the midline. For the reciprocal, that was an asymptote, remember? And then what's the flip of this? Just root 3. What's the reciprocal of 1 over 1? Still 1. What's the reciprocal of root 3 over 1? 1 over root 3. And what's the reciprocal of undefined? Well, go back up here. If undefined is 1 over 0, what's its reciprocal? 0. So let's compare tan versus cotan. So I'm first going to graph my tan graph. So we have 0, 0. Here, pi over 6 is 2 boxes. It'll be over pi over 6 and up 1 over root 3 is about 0.6. Like that. And then, well, I guess we could have just done the halfway method, but whatever. Pi over 4 is at 1. Pi over 6 is like 1.7. and pi over 2 is undefined. And then we may as well finish it since that's the going up part of the S. You know, that going down looks like that, right? And then these guys are points also. Halfway up 1, connect, halfway down 1. So that is tangent. So now let's see what cotan looks like. So the first thing I want to point out is where tan is 0, cotan is an asymptote, right? So all points on the midline for tan become asymptotes for cotan. And that includes this one too. And this one. And the next thing to point out that all asymptotes of tangent become points on the midline for cotan. So literally with cotan and tangent graphs, the asymptotes and the points on the midline swap places. So the points of tan became the asymptotes of cotan, and then the asymptotes of tan become points for cotan. And then watch what happens. At pi over 6, it's at root 3. So here's pi over 6. And root 3. And then pi over 4 is still 1. So notice that those are the same, very interesting. So at the pi's over 4, it's 1. And then at pi over 3, it's 1 over root 3, which is approximately 0.6. And then this here. So that's what it looks like. So we're going from here to here. And then like I said before, it's the following. What makes this graph easy to do, for me personally, just like with the other reciprocal trig, the sine and the cosine, I like to have, for secant and cosecant, I like to have their reciprocals drawn first. So I actually like to graph my cotans this way, where I graph the tangent first, and then I do the cotan. So once I have my tan drawn, I know that the asymptotes and the points switch, right? And then what's kind of cool, if you guys notice, this is cotan, right? From asymptote to asymptote. So this point on tan is actually a point for cotan. And then this point on tan is actually a point for cotan. And then it's a falling graph instead. Kind of neat, huh? Looks like pretty wrapping paper. So what happens to the graph of cotan when tan crosses the x-axis? They become asymptotes, right? And then what happens to cotan at the point where tan has an asymptote? They become points on the midline. So they literally switch. Their zeros and their asymptotes switch places. You ready to get into graphing? Yeah, you are. Okay, let's start with an easy one. Let's do number 3, okay? So my midline is at 0 because there's nothing being added, right? My period size is pi over b, which in this case b is 1, so it's just pi. Now that's the size of the period. And then just so you guys know, the formula to find the vertical asymptote is actually not for cotan. This is the formula to find the vertical asymptote for tangent, right? So if I find this vertical asymptote, which is pi over 2 times b, which is 1, I get pi over 2. Now this is an asymptote for tan, right? So if that's an asymptote for tan, what must it be for cotan? A point, right? So remember that those two switch. So if that's too hard for you to keep in your mind, which is totally fine, if you can do that whole switch of the tan and the cotan in your head, totally cool. But this is actually why I personally prefer to draw the tangent graph and then switch things up to do the cotan. All right. So just to make it not so confusing, I'm going to draw my tan in pencil. So my tan graph, everything is the same, right? My asymptote is at pi over 2, specifically every other. And then my point on the midline is halfway or at pi. It's also at 0 and 2 pi. And then I need to go halfway and down 2 because that is the amplitude, and halfway and up 2. So there's one full period of tan. It's helpful to at least do one more when you're finding cotan this way. And it honestly helps you practice more too. So I wouldn't consider it more work. Like, you guys are going to see how quickly you pick this up. And it's just more practice within one problem to do multiple periods. Okay, so we have tan graphed, right? That's tan. So now let's get cotan. So for cotan, again, as a reminder, whatever is an asymptote for tan, that becomes a point for cotan, right? And then whatever is a point on the midline for tan is an asymptote for cotan. So that point on the midline is now an asymptote. This point on the midline is now an asymptote. And then what's kind of cool is we actually already have the points, because this point that we drew for tan is actually a point for cotan. And same with this one, it just becomes a falling graph. And boom, you have one cotan period done. So that's one period. And then I'll do another one just for good practice. Done. So that's 2 periods for this cotan. So that works too. This is what you guys are going to see if you check my keys. You'll always see like pencil or a different color to show that I did tan first and then I switched everything. But if you can keep it wrapped up in your head that this asymptote does not go with cotan, see how like the asymptote is not at pi over 2? If you can remember the switch in your head, totally fine. All right. Okay. Why don't you guys try this one and or this one? So I'm going to pop up with answers to both of them. So if you want to do both, you can. If you only want to do one, that's fine too. But we're going to do number 4 first. I'm going to have you guys pause, go ahead and try this out on your own, and then I'll come back with the answer. All right, so again, I like to do the tan first. So this is tan all worked out, and then I'm going to go in with pen and do cotan. So as a reminder, points on the midline become asymptotes. So this is the one that you guys should be checking as your final cotan answer. And then the asymptotes for tangent become points on the midline for cotan. And then these points remain the same. Boom, boom. And hopefully this is what your graph looks like. So it's literally the parent, but shifted up 4. I figured we'd do a nice easy one to start. Okay. Now let's do a phase shift. Again, I personally still like to do tan first and then do cotan, but it is completely up to you. So I will come back with tan and then cotan. All right. So you can go ahead and pause and try it out. Okay, so this is my phase shifted tan graph. I didn't do cotan yet. So I just kind of want you guys to see what this meant. So that plus means to the left by pi over 4. As you guys can see, pi is 6 boxes, right? So if pi is 6 boxes and we want to find what pi over 4 is, you would do 6 over 4, which is 3/2, which is 1.5 boxes. So I took my first vertical asymptote, which was at pi over 2, right? And then when it shifted left pi over 4, I went to the left 1.5 boxes. So that's how I came up with this guy. My other vertical asymptote would have been at every other pi over 2, so that would be at 3 pi over 2, but then I went left 1.5 boxes. And then my points on the midline, which was at pi and 2 pi, those also went to the left 1.5 boxes. So everything shifted to the left by pi over 4. So this is my shifted tan graph. So now I'm going to go in and do my CoTangent graph. Again, if you want to kind of test your ability right now, go ahead and pause the video, and then we'll see if you got it, okay? So go ahead and pause right now. Okay, so to see if you did it correctly, again, all asymptotes of tan become points for cotan, and then all points for tan become asymptotes for cotan, like so. So that's one period, and then these points are gonna go with my graph. So if you just did that one, very nice. You also could have done this guy and that guy. Cool. All right, so that is tan and cotan, guys. Let's check out for homework. Because this was split into 2 different tasks, I'm going to pick and choose from each of the homeworks. So we're going to do RSG 6.9 and RSG 6.10. From RSG 6.9, you're only going to do numbers 1, 3, and 5. All 3 of those are just tan practice, so just tan graphs, okay? 6.10, you're going to do numbers 2, 3, 6, and 7. So all of these, that's only 7 problems for homework. Again, you guys are getting much less homework than you would if we were in school right now. But just to kind of break it down, so these 3 are going to be tan graphs. Okay, these 2 are going to be cotan graphs. And then 6 is actually a sine graph, and 7 is a cosine graph, just because I don't want you guys to lose practice on those 2, because we're going to be having one collective test. So I still want you to have practice on those. Cool, so we have tan, cotan, sine, and cosine graph practice for homework. And this is going to be due Tuesday by or before 4 p.m. Have a good day, guys.